Okay, so welcome to my talk about Go, an introduction. What I will show you today is a quick overview over the language, how it got created, then an introduction to the syntax and some of the concepts, and then some links for further reading, how you can educate yourself in case you want to learn Go. So, quick overview. Go has been created by Google in about 2009 by 3 engineers. It's open source. It's a programming language which is compiled and statically typed. One of the goals goals of the language were that you have a fast compilation, so you can iterate quickly on the code you produce and compile and see the result in a speedy way. Then the syntax should be small and easy to read. The language is also garbage collected, so you don't need to care about freeing of memory. There are good concepts for concurrency, so that is as well easy to do, and I'm going to show you later how that works in Go. You have a strong standard library, you have implementations for an HTTP server and client, you have encryption libraries, you have CLI flag parsing, I/O and OS-dependent things, and much more. When you compile a Go program, it outputs a single binary. What that means is that it's very easy to deploy. You just compile for the target machine, you copy the binary and run it. So much simpler a deployment cannot get. Then tooling, Go comes with the Go program, a CLI program, where, for example, you can call GoFMT. You can format code with that, so you don't have unnecessary debates about tabs versus spaces, for example. You have GoGet, which downloads and installs packages. There's GoBuild, which is used for the actual compilation of your program. GoInstall, which in turn calls actually GoBuild, and then sorry, that was a bit too far. GoInstall, which compiles the binary using GoBuild and then installs it to the correct location. GoDoc, used for viewing the code documentation of your own program as well as for the standard libraries documentation. You can also spawn a web server in order to see it in a browsable way. Then last but not least, there's GoVet, which is a tool for statically analyzing your program, so you can find potential errors in the code. Some of the Go users, which I found on the internet, there's much more, but whenever you use Google by now, you probably use some Go output. Then Kubernetes is written entirely in Go. Migros has some implementations in Go, Syrup, as far as I know, as well, and various others like Netflix and Docker, etc. So let's go. To get started, you can download the distribution on golang.org. Or on macOS, you can also just call brew install Go. I'm sure there also are packages for Debian, etc. There are various IDEs which you can use. IntelliJ has, for example, very good support using a plugin or a separate IDE called Goland. Then there's Visual Studio Code, which has very, very good support for it. and Atom and Sublime Text also have support. The first thing which you're going to have to learn when you work with Go is the Go path. It is the workspace where you place your source files, and also Go install will place the compiled binaries in a correct location. So the Go path you can choose freely. For example, in my case, I have it's in my home folder called home folder / Go workspace. Then the first thing there is a source folder. Below that folder is all your Go code. It does also the same way you structure your code, the same way you do packages or import packages, the same way you should also structure the folder structure of your Go code. So for example, if I create a repository within the domain gitlab.liip.ch under the path Michael Weibel / gointro, then you should also create the Go files in that kind of directory structure. The same way you will also import third-party dependencies. For example, if you rely on a GitHub dependency, you import it also using the full import path. Then the Go path will also contain a bin folder. That's where Go install creates the binaries. To show that, I have a short demo. If you can read that, maybe I'll make it slightly bigger. That's just a very small Hello World example, as you're used to from other languages as well. So that's within my whole Go workspace. If you look at that here. Then to compile that, I'll first remove the build binary so you don't. So you can call go install the compile demo, and that's done. And you can call then compile demo to execute it, and yeah, you get Hello World. As you've seen, well, this is a rather trivial example, but installing that or building that is quite quick. Then onto the syntax. So you can declare a variable using the var keyword, name for the variable, and the type of the variable. In this case, the type is string. Please note that the type is always after the variable name. That's different for example, compared to Java. Once you declare the variable, you can also assign a value to it. So name is now Michael Weibel, for example. You can do that also in a shortcut, which is what actually is used mostly. Declaration and assignment in one, you can do using h : = 29, for example. There are a couple of types, for example, slices. Slices is what you're used to from other languages as arrays. They have a different name because of some reasons I'm not going to explain here now. But basically, slices are the same as arrays from other languages. So you can create a slice of types where each item has a type string, assign some values to it, and also append more values as you wish to that variable. Yes, please.
Don't you also have arrays?
You have, but I'm not going to show it to you because time. Then you have maps. Maps are, as you might guess, key value stores. You can say what type the key has, in this case a string, and what type the value has, in this case, an integer. So you can assign values to it, and you can also later on add values or obviously read them as well. Then, as you've seen before with the compilation demo, you have packages. So every Go file lives in a package. In this case, the package is main. This main package has a separate meaning apart from being just a package. It's when you start a Go binary, it will execute the package main, in the package main, the function main. So that's the entry point to your application. Then you can import other libraries. For example, FMT is from the standard library, and then just go on using that. Visibility. So what you know from other languages as public, private, and protected, for example, is handled in Go using capitalization. So in this case, the display names function is visible in public way. So any other package, depending on your package, can execute that function. The concat strings function, on the other hand, is only visible in the package level. So only users within the same package as the concat string function can execute that function. Speaking of functions, so you have functions which can have, in this case, no arguments and no return value for the display names case. Then getNames has one return type, which is a slice of string. PrintName, on the other hand, has one argument called name of type string, and execute has two return arguments. Two return arguments are used very often. You can also have more than two return arguments. But they are used very often, for example, as in this case, for error handling, which I'm going to show a bit later. You can iterate using a for loop over slices in this example. The for loop can range over the length slice, and it gets back basically the index and the value, always in this order. If you don't need to use the index, so you only care about the value, you can assign the index to the I don't care operator, which basically just you can use it everywhere, but it indicates there would be some value there, but you don't actually care about it. You don't need it. Then the same way you can iterate over maps. You can range over a map, and then you have, instead of index and value, you have key and value, exactly the same way. So now when you used all the standard library data types, you can also define your own types. You can define types as kind of aliases to normal types. So you can, for example, say, I create now a type tz, which is an integer, for example. So just as a separate name, indicating that this has a special meaning. Or you can also create a struct, which is kind of like an object from other languages. So in this case, the user struct contains a field named name with type string, and you can also instantiate that user in a simple way. What is special here is the JSON tag, as you can see there with the backticks. Backticks are used to create tags for standard library or also own implementations. They then can use reflection in order to read the tag on a field. And in this case, the JSON tag means the name field will get serialized into JSON as lowercase name. Pointers. So while this might scare you, it doesn't need to be. Pointers are very simple in Go. You can use them to pass a object as a reference. So in this case, u, which is of type pointer to user, will get a reference to that user. What this means are two things. Pointers can be nil, so you need to check if the pointer is nil, otherwise you will get a panic. And the other thing is that the update user function can change the user which was given to it. So when u.name is set to some other name, the caller of that function will have the same value later on. If you would use not a pointer, then the caller of that function would not see the change. Then, speaking of the caller, so update user, which gets called from the main function, gives the user with the ampersand operator, and that indicates that it gets the pointer to the user. That's about it. That's pointers. You cannot do any pointer arithmetic, for example. So you cannot, let's say, increase the memory address of the user by 2, and then you suddenly get a buffer overflow or whatever like that. That's not possible in Go. Next, error handling. So, as said before, you can have 2 or more return types to a function. Error handling in Go is done through simple values. There are no exceptions. In this case, JSON.marshal returns also a type string for the marshaled JSON, or a type error for the error case. So whenever you call a function which possibly returns an error, you need to handle it. You need to handle it very explicitly. If you don't handle it, nothing will happen. Nothing will happen. It will ignore it, and then later on, when you try to use that variable, you get, for example, a nil pointer exception, or for if the res type in this example is a string, then you have an empty string, for example, as the actual return value. So that's very important. Whenever you call a function with error, which returns an error, you need to handle it, and you need to be very thoughtful about how you handle it. Yeah.
If you omit handling the error or commit any other bad authorship, will the compiler compile, or rather help you, or not compile, or
so the question was, if you ignore the error value, what happens if the compiler will error, for example? No, the compiler will not error. So there are tools which can help you spot missing error checks, but the compiler itself, for him, it's okay.
So these are plugins then that you can...
Third-party CLI programs. Methods. So in Go, you also have no class keyword. So what this means is not that you cannot have methods. It means that you can assign methods to any type you define on your own. So in this case, we define a method called string on the user struct, which we declared earlier on. That string method returns also string type and just returns the u.name, for example. Also here, very important to know is the same thing about pointers. So whenever you want to adjust something on the user in this example, you need to get a pointer to a user, because otherwise the caller of the function, or the user itself in this case, will not see the change. So the change would be only local to within the setName function in this case. This way, as said, this way you can assign methods to any types you defined on your own. For example, you can also have a type tz as before with an integer, and then you can assign a method to that type and use it just like you would use a method on any other struct type, for example. Yeah, U in this case is called function receiver. Then using methods. So when you have a user instance, you can just call user.setName, and that will call that setName method. You can also call fmt.println on the user, and that will call the string function. Coroutines. So this is now the more important and interesting part of the whole language. Coroutines enable you to run kind of threads, but they are not really threads. So it's very lightweight processes which you can spawn. You can spawn in normal commodity hardware. You can spawn millions of coroutines without any problems. So that enables you to code in an asynchronous way. In this case, we have do something, a function which does some maybe long-running code, and the function main calls the do something 10 times. The special thing about that is the go keyword before the calling of do something. So the only thing you need to do in order to make a go routine out of a normal function is you prefix it with a go keyword. That's it. So you can this function will now spawn 10 times concurrently. Now, when you have go routines, the issue is that you don't really are able to share data between those. So for that, there are channels. Imagine you have a long calculation function which runs very long. So you want to execute that as a go routine, but you also are interested in the result of that function. So what you can do in this example, you can create a function which acts as kind of a wrapper to that long calculation function, which takes the integer which you use to do the calculation and the channel of type int. So the async calc, when that gets executed, it runs long calculation with A, and then as soon as it's done, it sends the result to the channel C. So when you want to call that, you create a channel, you make a channel of type int, you call go async calc with that channel, then you do some other stuff, whatever you need to do, and at some point you read from the channel C again. And that's where you will get the result. If the result is not there yet, you will wait, you will block the whole program until there was one message to the channel. I have another short demo, which is a simple HTTP server, which is kind of related to Go routines, but you don't see it really. So the standard Go library declares the net HTTP package. You can import that with ease, and then you can define handlers based on some pattern on the HTTP server. and you can start it on port 8080 in this case. Listen and serve will spawn a HTTP server and will block until you quit the program or until an error occurs. So that's why here log.fatal will exit the program and log the error output, which may come from the listen and serve once it completes in a wrong way. Then here you have those two handle functions. W is the response writer, so there you can write the response to it. And R is the request, where you have all the details about the request, like the URL, the whatever, headers, whatever you need. Now to compile that, I can just, if I would be able to write, just call HTTP demo, go install, execute it, and then it's running. And where is my browser? Sorry, 1 second. Oh yeah, right. So you can go to localhost 8080. And there you have that. I can also do that. And then that's the root handler, how I called it. And then the test handler is outputting test. Yeah. So that was mainly it. So further reading. I didn't show you all of the language. For example, arrays is one example which I left out intentionally. Then interfaces, which deserve an own talk on its own, and various other things, obviously. So especially in Go, it's very important that you know the standard library well enough, because it's really big, and you don't necessarily need to depend on a third-party package, because the standard library is so comprehensive. So the official website is golang.org. You find there the binary releases, etc. There's the playground, where you can try out Go in a very simple way. You can execute it online, and your code online, and yeah, share also code snippets with colleagues. There's the Go tour, which I recommend to get an overview over the whole language, over all the syntax, and also it gives you a good idea as to why the inventors of Go did it like they did it. There's the online documentation for standard library packages, as well as all third-party packages which are published online. Now, if you want to get started, there are two repositories where you could contribute. One is Sheriff, which is a marshaller similar to JMS serializer, for example. And there's a brand new library for Rocka written in Go, which needs some contributions in order to make it complete. That's it. Join us in the Golang channel and questions.
I have a question. Just wondering about the memory management when you pass around variables. Is it copy on write, or because I remember back in the day in PHP, it was like an optimization to pass everything around by reference, so you wouldn't copy data. How does that work in Go?
In Go, it's copied effectively. If you don't use a pointer, then the data is copied. And that means that in most cases, it's okay to copy the data itself, because it's usually slightly easier to work with non-pointers than with pointers. However, if you have very big structures, then it may make sense to pass a pointer instead.
The net HTTP package, does that automatically encode the outputs, or does that do any magic in that way?
What do you mean with encode? Like HTML escaping?
Yes.
Or no, this you have to care for your own, basically. So it's very bare bone in that way.
When you have one of your Go functions as a thread, how would you check the state of what's happening in there? Is there like an event system, or?
This you then can do with channels. So you can pass the channel into that Go routine, and that can report the state or whatever is needed to the outside.
Thanks.
Good. Thanks.